Hey, hey! Okay, hi guys. I'm really excited to be here again and again and again. Today we will talk about JavaScript Robotics after two amazing lectures we've seen from previous speakers. We will dive a little bit deeper into the code to see how to use Johnny 5 library, how to use several chips and devices. Bear with me. Let's start with no. Thanks. Okay, I didn't forget to record the screen and I set up the camera. Okay, a little bit about myself. In addition to what Shai said, my name is Vladimir Novick. I'm a web architect and consultant, part-time in Code Value. Rest of the time, I'm involved in several projects doing IoT, web, mobile, mixed reality, and virtual reality stuff. And today we will talk about several things. We will talk about JavaScript Robotics with NodeBots. We'll talk about what is NodeBots, what is Johnny 5 library, and we'll see several chips. We will talk about Internet of Things in general and about some specific implementation of connecting our device to the cloud. And we will have fun with cool demos. Hopefully they will work. I have a case here. Actually, one security thought it was a bomb. Today, it was okay. I wasn't stopped in the entrance, so yeah, surprised, really. Okay, so we'll talk a little bit about robots. Yeah, that's how it gets started. If you don't know, Boston Dynamics is an amazing firm acquired by Google for developing these robots and humiliating them like this. And this is what eventually will be. Okay, so we know what robots is. We heard about Internet of Things. Maybe most of you are probably aware that there are smart devices, connected devices, but probably you don't aware how much there are cities, actual cities connected to the cloud with various services. If we will see on this picture, we have connected cars, we have connected bicycles, trains, coffee machines, even we have connected toilet. That's right, we have toilet connected to the cloud that checks what's your urine type is and reports to your
how many times you poop. Checks your output.
Yeah, literally checks your output. And there are lots of devices that are running JavaScript, lots of chips, lots of boards running JavaScript. And basically, JavaScript is everywhere. JavaScript is on the Earth and even in space. There is a NASA project. They actually put Node.js inside the spacesuit. So you can say JavaScript is reliable. Eventually, I think somebody will die from the spacesuit. Not that I... yeah, let's hope not. But if we'll take a look at this picture, we all know that JavaScript is running on the server for like several years with Node.js. We know that there is MongoDB, which is basically JavaScript-ish. Have JavaScript running in the cloud, in Microsoft Azure and AWS. You have serverless architectures, Lambda and Azure Functions services which can run JavaScript in addition to running them on the server. We have JavaScript running in the browser, and of course we have JavaScript running on devices, which we've seen today and we will see right now. Today we will talk mostly about Johnny 5, the JavaScript Robotics framework, which was created and inspired by this movie. In a nutshell, a movie about military robots struck by lightning. And instead of going rogue and killing everybody, he got funny and good and helped people. And that's doesn't happen in real life. But let's see what is Johnny 5. As I said, it's a JavaScript robotic programming framework. It's built on really known as and considered as a standard firm data protocol for communication with controllers, with microcontrollers. And we will be communicating with several of them today. It was created by Rick Waldron in 2012, and it's maintained by a huge community. It's really considered a global standard now. Even they have NodeBots events and NodeBots communities around the globe. And I will hope we will, inside JavaScript Israel, will make happen all the JavaScript robotic going on the next meetups and maybe next sessions. We'll take it offline, right? Okay, and Johnny 5 supports a really wide range of MCU, which is basically programming microcontroller boards, and SoCs, which stands for System on Chip. It's stuff like Raspberry Pi and Tessel and other couple of systems on chip. Basically, as Uri said, it's a small computer running an actual Linux machine on it with pretty awesome capabilities and memory and stuff like that. So this is just an overview of the list of boards that Johnny 5 supports. It's small here, but you can go into a website, Johnny 5 website. You will see each board and the specification of each board. Later, in this presentation, you will get a link, and I will also post a link afterwards on the official website of Johnny 5. We'll post it there. So why we will bother to use Johnny 5 and write in JavaScript, right? So we don't really want to write C, right? I hope maybe there are some fanatics of you that wants to write C code, but I personally prefer writing JavaScript. There's no compiling, right? Like you run Node and you get all the benefits out of the running Node. You get real-time feedback from hardware. Usually when you run C programs, it's sometimes hard to debug errors that you have. You've seen it in Uri's examples, we have feedback like right away. We have console error or exceptions thrown out there, and they are very descriptive and lets us debug our application in a better way. It's JavaScript. We all love JavaScript. After all, we're in JavaScript Israel Meetup, right? Let's start a little bit of hacking. I have here, this is my webcam here, so if you're confused what's that, it's actually, it's a webcam. Well, I have here Arduino board, which is running firm data protocol, and I have a bunch of wires here set up to LCD, and let's run a simple program. Do you see? That's better, right? Yeah. Okay, so this will be in the repo. In the repo of slides. So if I go inside Arduino directory, I have Arduino welcome JS file, and I just run it with Node. I need to connect it, sure. Welcome. I hopefully will see something. Sorry, the moment lost. So I hope you can see. Have hello JavaScript Israel. I love Johnny 5. Okay, that's better, right? So, and I have a small button here. If I press it, I get ready for more cool examples. So are you ready?
Yes.
Great, but before that, let's look at the code. After all, we all came here to look at bits of code, right? So, Arduino welcome. Well, I said like plenty of times we will use Johnny 5. So, yeah, we are using it right now. And we have required Johnny 5. We define 5 board and LCD variables. Excuse me for the code, it's not super clean. It was for the sake creating lots of demos. So we have a new board. We just created with new 5 dot board. Yeah, the new 5 dot board. By default, Johnny 5 thinks it's an Arduino Uno. If you want to change it to a different board, we will see it later how it's done. But basically, you just pass configuration object and good to go. So then we call board on ready, like we would call with a document, but this time it's a real actual board. And then I define some counter and array of text arrays, kind of. Well, as you can see, as you probably have seen here, I have 2 rows, right? So I want the first row to this. I have 2 rows, and I clicked once, and then it changed to the other text, right? So in every row, I have the first row is ready for more, and then cool examples, right? So what I do, I define a new button, and then I define LCD with some pre-built values. Basically, pins stands for Arduino general pin. It's called GPIO, general pin input-output. It's connected to the board itself, to the pins you see here, and then some LCD-specific configuration. Johnny 5 supports a wide range of sensor LCDs, motors, stepper motors, buttons of various types, and lots of stuff. And then I define that I have 2 rows and I have 20 columns, something that came by trial and error. But basically, you can make your font smaller on this LCD by just providing more rows and more columns. Then probably you've seen I had like a heart mark, right? Instead of character, there are some specific pre-built characters inside for this specific LCD. So I can call use char function and use these specific characters. Of course, there are sets of pre-built ones. You cannot put any character. But still, it's a great feature for this specific LCD. And then I want to print. So I clear console, and then I print hello JavaScript Israel. And then I move my cursor to the next line. Then I print again, heart Johnny 5. When you see this code, it means to put the heart symbol there. And then everything works on startup. But still, I want to make it work when I push the actual button, right? So I basically need to define some kind of event listener for this button. It's done as simple as that. Button on down, I call the function. And I actually test if I haven't passed the boundaries of array, if I still have the actual text I want to print, and then I just for each this text and print and clear the console from each iteration. And then I increase the counter. So basically that's it. That's the whole application, right? The application, it's like several rows. And then I have this code, this .repl.inject, LCD, and button. What does it mean? REPL, it's kind of shell for the microcontroller. So you see I have a shell-ish thing here. So I can just type LCD, and I will get all the parameters of LCD in case I want to debug some stuff. And I also think, I don't have LED, I have button, right? Some specific parameters for the button. So this is something you cannot get from C, right? This is something you get from JavaScript. And that's basically the first example. Now let's check the second one. You ready for the second one? Great. The second one, I hope it will work. I've tested it several times, but you know it's hardware, and you never know. No, thanks. Basically, what I'm doing, I'm just explaining what I'm doing, so you won't get bored. I'm just disconnecting the device and connecting the other one. Yeah.
This hardware project, did you build in TDD?
Yeah, sure. Test LED physically. I just touched it, tested, it works, it looks like a LED, then it probably works like a LED. And it's not. Not always. It's a hardware, you know. It's
hard.
Yeah. That's why it's called hardware. Okay, so I have Tessel here. Tessel is system on chip. And now we will do some cool stuff, if it will work. This Tessel device, it's running JavaScript by definition. From when you purchase it, it just runs JavaScript from the ground up. You don't need to set up anything; it just works. It also has neat CLI tool you can use for connecting to it and connecting to Wi-Fi and do stuff. So we will try to connect to exit our REPL and connect to our Tessel. Have a library here, and I have a lot of certificates here because we will be connecting to the cloud. And let me check if let me just run it. It's Node Arduino, and I want T2. That's the CLI. I will run index, and I will hope it will work. If it won't, we will start debugging. But let's hope everything will work. As you can see,
Program for the Arduino, and then let it run not connected to the computer. Can the Arduino save the JavaScript program and run it disconnected from the computer?
The question is if Arduino can run JavaScript disconnected from the computer. Unfortunately not. For running JavaScript, you need things like Asperino, which Uri showed. But sometimes, and most of the cases, you will use Arduino as a pipe between your main controller, like Raspberry Pi or Tessel or whatever, system on chip. You will put some kind of microcontroller. Arduino will get all the data from sensor and whatever, and then publish to the cloud. So if your Arduino is connected to the Tessel or to Raspberry Pi, you can run Node on Raspberry Pi and just connect to Arduino. That's
so
basically
you
it.
can't take the program that you wrote in Johnny 5 and sort of compile it back to C or something to run on the Arduino?
Unfortunately not.
Okay.
Unfortunately not. You cannot take your Node program and run it on Arduino without connection, without any connection with the... Okay, it looks like it worked. So what basically this Tessel does, there is a weather sensor here from SparkFun. They build pretty nice sensors and hardware. This sensor contains temperature meter, altimeter, humidity, and barometer inside this small chip. It's connected to the Tessel, to GPIO pins, and when I ran this, it didn't crash, which is good. It's supposed to post messages to AWS IoT Cloud. Okay, so if we will refresh it, we will probably see messages getting into. We need to, with AWS IoT Cloud, You see, we get the messages. We need to subscribe to some topics. We will look at the code in a bit. But basically, if you want to build a connected device with AWS, with the whole scaling ability of AWS, it basically means you need to take some system on chip, some SoC, connect it using AWS device SDK, connect it to AWS IoT cloud. It's connected not through HTTP protocol, it's connected through MQTT, which is messaging protocol. AWS IoT Cloud knows how to save the data in its internal database, and there are some queries you can run on AWS IoT. And basically, you connect it to Lambda functions and Lambda functions to real-time service of AWS, and then through WebSockets, you can just read this data. The amazing thing that in between, like when the data gets from AWS IoT, which is raw data, you want to get some filtering in the middle, you want some processing, so you can freely do this with Lambda functions. And in the end, you will just expose the data UI needs and the data that maybe your some backend process needs, you will expose to different service.
This one can run without connection.
Yeah, the statement was that Tesla can run without connection. Yeah, that's right. I'm running it connected. You can just push your code to the Tesla and it can run connected. It can run disconnected. The same as Raspberry Pi or any system on chip. Tesla has Wi-Fi capabilities, Bluetooth, pretty decent memory, and in general, it's a good device. Though I personally prefer more Raspberry Pi because it's more configurable. You can run anything there, not only just JavaScript. You can do low-level processing and stuff like that. And in my opinion, it's much more powerful. But that's me. I hope who created Tesla won't hang me for this statement. But OK, so let's get back to the presentation. So we have Tesla here and the weather station, and you've seen everything is posted to AWS IoT Cloud. Let's take a look how it was implemented. So we have here Tesla, which is required from Tesla IO. You may ask, what is Tesla IO? Basically, when you create a board with Johnny 5, and it's not the default board, like it's not Arduino or any set of pre-made default boards, you need to configure to pass configuration object, which in turn needs input-output plugins, which are available as NPM packages. Tesla IO is IO plugin that we pass later on to Johnny 5. So I have installed Tesla IO here, I installed Johnny 5, and I have path because I'm running Node environment, and I have AWS IoT device SDK. Then I set up my board as we've seen earlier, but we also have new Tesla here, which is IO plugin. Then we have some built-in setup for IoT. We pass private keys, certificates, root certificates, client ID host. All this you get when you register your application in AWS IoT. You just get a zip file you can download. You have all PEM keys and SRT keys for certificates, and you just put it in the same folder. And as you've seen previously inside the, when I ran it with -- full, right? It means take all certificates and pass it if Tesla requires them. In turn, if I just push this code or this folder to Tesla, it will just work. I don't need to run it with -- full. And then when my board is ready, I create a weather monitor. Johnny 5 has was some function called multi. It's for some multi-controllers, multi-weather sensors. There are pretty bunch of them. Later on, if we'll have time, we'll take a look at the list that Johnny 5 supports. And then when our weather monitor changes, we just publish everything to the cloud. Okay? So now we get into the hopefully working cooler demos. I won't need a camera here, I guess. I have this small guy here. It's a Paradrone. Pero doing great job for creating drones with exposed API for developers. So you can hack into the drone and do stuff on the drone, stuff like that. Basically, I won't use now Arduino, or I won't use Tesla now. I will use another one, another SoC, system on chip. And yeah, that's the reason why they thought it's a bomb, right? The reason I've created it in such a weird way because I wanted it to be secure, but I don't know why I did it.
Everybody, please clear the premises.
Yeah. Okay, so I have a Raspberry Pi here. As you can see, it's okay. So I probably will disconnect the camera. It's okay if everyone sees what happens here, right? From the back, you need the webcam. It won't blow, so don't be afraid. Okay. Okay. So anyway, I have a Raspberry Pi here, hopefully connected to the same network I'm tethering. And let's do the following. Let's SSH to our Raspberry Pi. Hopefully, yeah. Wait. I'm excited, so I make mistake. I didn't make mistake in my password, so that's okay. Okay, so as you can see, it's just a Linux machine. I have like a bunch of libraries here. What I will do, I will connect to RPI drone library, and I will in another tab. Actually, I don't need another tab. What I will do, let's see at our package.json. We see there is a start. I am running just Babel node because I wrote my code in Babel, right? And I will run just npm start. And if everything works good, the drone will stop blinking and the LED will show us that we are connected. Hopefully. It's thinking. Thinking. I don't have permissions. Yeah, that happens all the time. So let's do just node index.js. Right, let's run it like this. The reason it needs sudo because it uses Bluetooth, and by default in Raspberry Pi you need to be. You see it's connected, and the LED doesn't work, which is strange, but it works, right? So if I hit again, it will land. Nice! It landed! It didn't crash! Okay, so it was only JavaScript, right? So let's see what was the code. I import Raspi from Raspi. I will probably should disconnect it. Or not. Let's disconnect it first, so it won't eat the battery, right? So disconnected, it will start blinking. Yeah, it blinks, so it's disconnected. So I import Raspi and Raspi.io for Johnny 5 drone, which is basically uses rolling spider parrot drone. It's a package created for this specific drone and the other one in the series for sending specific Bluetooth signals. Then I just pass IO with new Raspi and I create a new button. I pass it pin and it's pull up because this is a pull up button. Then when I hit down, the drone takes off and logs in the console that it took off and it lands if it landed. Okay, so it was good, it was nice, but let's make some more cool stuff. What? When I press and hold, I can make acceleration. Definitely, I can do that. It's okay. It's okay for this meetup. I have other drones that are voice controlled with acceleration. It's just too long presentation to show. So we'll talk about React-IoT, which is a combination of not working slides. It's zoom out, right, nice. So it's a combination of Johnny 5, React Fiber Custom Renderer. Basically what it gives me, it gives me an ability to take React code written for the browser in the browser, put it on the Raspberry Pi, on the device, and it will run with the physical hardware. Why I choose to do that? Because, well, React ecosystem is used everywhere, unless it's Angular. Because using React way of thinking, like combining components and composing components, I wanted portability from web app to IoT app, and I just wanted to make fun, which is basically the main reason I did it. So now we will do the following. I have, how much time left? I've left. 5 minutes. Okay, so I have a web application here, and it's like a drone controller. And what I will do, I will exit from my Pi, and I will go inside my presentation directory. I will run the server. No, it's my machine. It's sudo by default. Okay, so you see it's connected. So now it's connected. Basically what I will do now, you will see this turned on, right? So take off. Let's go up. And rotate a bit. And right. And I can land. Okay. So it's a web application, and thanks. So the code. I hope I will have time, but bear with me. Let's take a look. Basically, I have, you've seen I ran Node server. I have a server here. The code of the server we will see, but eventually it outputs, connects with the socket IO through the WebSockets. And when I press the button, it emits socket IO event into the Node server, which in turn runs the same drone library I did in the Raspberry Pi. So here I have like a basic React initial setup, have state which is connected, in error which is false. And when my component did mount, I connect to socket IO client, which runs locally. When it's connected, I set state to connected. And that was the red button you've seen when it gets connected. Then when it did off, you've seen the button changed from take off to land.
Where does the Pi connect to the socket?
we don't have Pi here, and we will port it. The question was, where is Pi connected? Pi was not here. It's only the computer. And now we will port the same code on to the Pi.
So it goes Bluetooth to the...
To the, right, to the drone. And when it did land, it turns this state to false when it changes, and then just basic setup of things. On server, we have socket I/O, and we have when we are connected, we emit connected. Then on the client, you will see the red button. When it took off, when it took off, you will get emit of the takeoff, and then the button changes. Then the button changes from takeoff to land, and then all the basically connection to the move and left and right and rotate and all this stuff. So let's now take the same code and port it to device. It's blinking. No. Because I still run the server, right? So now we will port the device. We will leave the same server code because it's running Node, and we will take client-side code and we'll change it to meet React-IoT requirements. And then we will SSH to Raspberry Pi. Basically, what we do here, let's SSH to Raspberry Pi. Yeah. We SSH. So we go inside the dev, and I don't have aliases here. We have a React-IoT presentation example, and I have two folders here, IoT and server. Let me run server. No, it's I've changed it, I think. Yeah, there is sudo. I've changed it in package.json when running npm start. And then meanwhile, let's connect to another shell instance, connect into Raspberry Pi again with SSH, and then we will run the client code, and we will hope it will work. We will hope it's connected, right? The server said that we are connected, and single strength is really low. What can I do? That's the drone. And now it's connected, the LED works, and yay! Now it will blow up, and we all die. Yeah, and now we have the physical buttons and stuff like that. But we've seen it already with Raspberry Pi. So what's new here, right? Let's take a look at the client code transformation. We have React, we have Raspi from Raspi IO, we have Socket IO, and we have app registry, board, LED, button, container. We have the same state we had it with React. It's connected in air. We have the same component did mount we had previously. We have the same code. But in our render function, we have container, and we have LED with pin number. It's the pin number where the LED is connected. And when it's on, we get this state connected. So we have all this state update mechanism of React and structure. We are writing React, but under the hood, it works with Johnny 5. We do have containers here, but actually in hardware, tree doesn't matter. We have flat structure with its physical buttons, right? It's not like this button will disappear. It may be, but until I'm looking at the device and it won't disappear so easily. I will fight for the device I've created. We have, yeah, it can blow. So we have container here, which is basically just a simple wrapper. It does nothing, but it's good for keeping the same structure. Like if you have web application with geometry, with a structure. You can still keep the same structure, but get the logic. And then when it's pull up, and when I press, I have I emit move or up, and in the end, I have to register my IoT application. That was something I got from React Native. In React Native, when you start your application, when you register it, you have a module called the app registry, and you register your component, which basically registers it with Native Bridge. The same kind of thinking was with this library. When I register my component, I basically register it with the root element, which is the board. And we get the same config we passed before to Johnny 5. In fact, this is the config that will get passed to Johnny 5. There's no magic here. It's not a lot of code here. You can see it on GitHub. It's small. So main reason it was done for fun. Yeah, and it was already on device. Okay. So what is under the hood of React-IoT? Have custom fiber renderer. React initially started with a stock renderer. It was React renderer. Basically, what it does, it calculates all the diffing mechanism. And in recent month, half a year, actually recent months, React got updated with a new diffing mechanism called fiber. Basically, you can build on top of this mechanism, on top of fiber mechanism, and create your renderers yourself. It's not that complicated. It's like a lot of things to override because I don't have DOM tree here. I don't have DOM events. There are lots of things that are coupled to the DOM. I had to override or just disable. But as you can see, it's possible to take React code and just port it. Initially, React-IoT and the name React-IoT was inspired by Uri when he created his React of things in React-IoT library. Yeah, I was trying. When he created his Angular of things in the Angular IoT library. So I wanted to do something with the React, and it worked. It has the whole power of Johnny 5 framework. Well, it's a bit of lie because it has a power of the ecosystem of Johnny 5, and like for now 4 or 5 centers supported. But it plans to support. The plans are to support every bit of Johnny 5. I'm almost done. So. The plans will be later. There is another project though that was created before me. It's called React Hardware, and it's basically follows the same idea. You write React, you render it on the physical device, but it gone in the different direction than Johnny 5. I myself and lots of people consider Johnny 5 as a standard for NodeBots and writing JavaScript for devices. This project, React Hardware, which is amazing by itself, but it took the approach to take the low-level firm data protocol and implement the clone of Johnny 5, but inside React world. For now, it supports LEDs, sensors, temperature sensors, buttons, and small stuff. Basically, almost the same thing I support in React-IoT. And it was also done for fun, for some presentation, or whatever. It's also good if you have Arduino, you can still use it, React Hardware, but it probably won't run on Pi, and probably won't run on Tesla and devices like that. So, what is my roadmap? The roadmap is to implement all Johnny 5 components, of course. Add connection providers, AWS IoT Platform, Azure IoT Hub, and Google Cloud IoT. The idea is to give you the simple API to connect to AWS IoT or any cloud outside of the library itself, or at least give ability to port MQTT connections to inside the library and do connection pretty simple. It's planned to add extensibility with middlewares, plugins, etc. Hopefully it will work. So I really want people to contribute. If you want, go to GitHub, say, hey, I want to contribute, file an issue, try it on different device. I tried it only on the Raspberry Pi. There are tons of devices that can be tried. In general, it's supposed to work on every Johnny 5's devices, because as you can see, you just pass the same configuration object, but who knows? And probably in JavaScript Goodness Squad, we will someday have this project there. If you want just to talk or read things I write in my social media and stuff like that, you can go to vladjs.com, which was my crappy website, and my Twitter account. And thanks a lot. I hope you enjoyed. The drone enjoyed. Thanks.
Pum 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 pum.